So in last session we discussed about how to create measure groups and how to design on how to add dimensions to the cube, and we also discussed about a little bit about relationships between dimensions and the fact tables. But in fact we have not given any relationships. Everything automatically taken by SSAS. Now in this session we are gonna concentrate only on relationships, how to give relationships and why it is important. Actually we discussed about this point, why it is important to give relationships. So in this session, how to give relationships and what are the different types of relationships available. Before going there, I deleted the cube what I have created to demonstrate the option create cube using existing tables. I think you people, I hope you people remember that. I deleted the existing cube and I created a cube using the option use existing tables before signing off the last session. So now what I have to do, I have to create a cube as we are going to discuss about relationships. So I'm going to create an empty cube first, and I'm going to create a couple of dimensions. So let me take dim dimension. This is fine. I will add all the attributes. I'll name it as time, and I created a dimension time. And the next thing, I'm going to create a dimension for products. Let me go to dim product. This is fine. And let me name it as product. And I'm going to create one more dimension. It is for, let's say, customer. No, customer does not have primary key. Right now I don't go with that. I'll come back to the customer for sure. Let's go for promotion. What is this promotion table consists of? This promotion table will have the information like offers. When the offer is Diwali sale, what is the sales? They just want to know what is the sales for a particular, when they released, when they announced a particular offer. For example, Diwali offer or Christmas offer or Thanksgiving offer, whatever it may be. If you see the English promotion name, this one will have the information about what are all the different promotions given by the companies. Okay, now the next step is I have to add the measure groups. So let me add, I'm gonna add a measure from sales, and the measure is sales amount. So here I'm gonna rename it to sales, and I'm gonna add one more, that is tax amount. I'm gonna rename it to tax. Okay, now the next step is adding dimensions to the cube. If I add the dimensions, automatically the relationships will be set here. Why? Because I have given the relationships in the data source view. But this session is completely on relationships. So what I'm going to do here is I'm going to remove the relationships in the data source view and then add the dimensions to the cube, so that the relationships will not be set here, and I can explain you how to set and which one to take. Okay, I think this is the best way of explaining the relationships. So what I'm going to do here is I'm going to remove the relationships that I have. Time relationship is already removed with the fact table, and I'm going to remove promotion relationship, and I'm going to remove the relationship between product and the fact table. Now I've created dimensions with these three tables, and these three are not having relationship to the fact table. So that means if I add the dimensions here, all the three, I click on OK, you can see the relationships are not set by default. This is because the relationships I removed intentionally from the data source view. Now before going to the next step, if this is your fact table, okay, And if this is your dimension table, while doing analysis, let's say for time, okay, the year column will be coming from this dimension, right? And the sales amount will be coming from this table. So these two combinedly will give you the year wise sales. So if I don't give relationship, if it is like this, what you are seeing here, that means no relationships. You can see no relationship for anything, right? So if it is like this, then it won't give data properly here. The year-wise sales or quarter-wise sales, whatever may be the attribute you pull, if you pull an attribute from product dimension and if you pull a measure from sales, it won't give proper result. Why? Because the relationship is not set between these two. In the same way, if you pull any attribute like promotion type from promotion dimension and from measure group, if you pull some measure, it won't give proper values. Why? Because the relationship is not set. So if the relationship is not there between the dimension and the fact, then you cannot use these attributes from this dimension and measures from this dimension to do your analysis. Why? Because it will give you junk data. Now if you see here, if you want to get proper data when you drag time related dimensions, that time related attributes, that means like a quarter, year, any attribute that belongs to the time and any measure from the sales, and if you wish to have a proper data, a proper output, then you have to make sure what is the intersection point of these two. The time and the sales, the intersection text box is this one, where it intersects. These two are intersecting at this point, so this should not be blank. This should be filled with the relationship. In the same way, if you want to get proper data when you drag any attribute from promotion dimension and any measure from sales, then what is the intersecting text box? Intersecting box is this one, and this should not be blank like this. Okay. In the same way, if you want to get proper data for when you drag product attributes and the sales measures, then you have to give the relationship. So this is why, this is the problem. If you don't give the relationship, the main problem is it won't give you the proper data. So now I hope you understood which relationship to be given, either this or this or this, to get proper data between product and sales. Which one we have to set? We have to set this text box. Why? Because this is the intersecting point of these two. This is where we have to specify the relations, saying how the sales table, that is fact and net sales table, and the product table is related. In the same way, promotion table and the sales table relationship should be given here, the intersection point. In the same way, for the time, this is the place where you have to specify the relationship between the fact and the dimension table. Now, let's see the different types of relationships. Before going how to give relationships, the concepts of giving relationships, let's see what are the different types of relationships available. To see the different types of relationships, you can click. First, you have to click on the text box, and then you will get a button or icon, small button here. If you select this, the wizard to define the relationship will be open. The first option is relationship. Based on the first option, the relationship type, the text boxes here will be changing, or the enterable fields, I can say. This will be changing based on the first option that you are going to select, that is relationship type. And if you ask me what are the different types of relationships available, this is the answer. I have 6 relationships. One is no relationship, second one is regular, third is fact, fourth is referenced, fifth is many to many, and sixth is data mining. So data mining, let's say this is not in scope of this training session, this particular training sessions. We're going to discuss about the remaining 5 here. And you are very well aware of the first type, that is no relationship. No relationship is nothing but if you don't give any relationship, this is the one. This is also no relationship. This is also no relationship. If you feel that you are not going to see the data based on this time dimension and this sales fact table, then you can set it as no relationship. Why? Because as per my requirements, I'm not going to see the data time dimension wise, sales amount. Okay, that is why the no relationship is there. It should fall in any one relationship. If not, then no relationship. Okay. Now, before going to the regular relationship, I want to demonstrate an example in SQL Server why these relationships and how this one works. Let's go for first fact table. Select sum of sales amount from fact internet sales. Okay. So what this one will give? This one will give you the total sum of sales, right? Now select distinct star from dim product. So this one will give what are all the different products available. If you want to see in particularly products, English product name, if you select this, this is gonna give you the different products that are available in the dim product table. So this is the output that you are gonna get when you drag and drop measure, when you drag and drop the sales amount measure, and this is the output. Let me execute both. This is the output what you are gonna get when you drag and drop only measure, and this is the output you are gonna get when you drag and drop only dimension. Let me show you the same. I have to give relationship to at least one dimension, as I told you in last session. So let me go for that now. I'll go for order date key, some blah blah, some testing one. I'm not going to make use of it. I'm going to demonstrate the product and the sales here. What will happen if the relationship is not present? How it is going to take the information. So I process this. Now the relationship is given between time and sales based on order date, and I'm not going to worry about it. What I'm going to show you here is how the data will be shown when you drag and drop some non-related fact and dimension. So as I told you, if I drag and drop sales amount, it is giving me 2935867 something, whatever it is here. So that means it is giving the sum of sales amount, right? Now if I remove it, if I drag and drop product, that is English product name, it is gonna give me the same output that I'm getting using this particular query. What if I drag and drop color? Color is a column from this dim product table. Color, it is there. So what is the output? What will be the output if I execute this? I'm gonna get only these 10 colors, and let's see the same in SSIS browser. So I'm getting the same 10 colors information. So whenever you drag and drop an attribute, what it will happen is it will take the distinct of that particular column and show it here. Whenever you drag and drop a measure, then it will take the aggregate function and get the information. If you don't relate these two, let's say for example, if you don't relate these two, if there is no relationship between these two, then the data will be like this. Data will be like this. You can see all the dimension, all the column values, and same value for all the values, all the dimension attribute values, right? Dimension attribute members we call it as. So that's the problem. Using this information, can you identify what is the sales for adjustable race? You cannot give that information, right? So in the same way, here, if you use inner join with the dim product table on some condition is dot product key is the common column. is equal to fact internet sales dot product key. So now what I'm doing here is I've given the relationship. As I have an aggregate function here, what I have to do when I have an aggregate function? First, let me take the product name. I have to use the non-aggregating columns in group by. So I'm giving group by English product name. So there is some problem. Let's see what is that. So here I have taken test. It is not test, it is dim product. Okay. So if I execute this, now it is giving the information group by this particular attribute. Instead of this particular attribute, if I select color, it will give color wise information, right? Sales amount. So the important thing that you have to get from this particular query is the relationship. If you don't have this, then you cannot get anything. So the relationships plays a major role. Attribute, you can change whatever column you want. English description, if you want, you can go for English description. But the major and the most important thing is the relationship. So if the relationship is proper, if the relationship is given, then only you can aggregate the data and see the information. In the same way, if you have the relationship between the dimension from which this attribute is dragged and the measure group from which this measure is dragged, then only you can see the data properly segregated. Now, how to identify which relationship to be taken? That is the next challenge. Now you know how it works and what you have to do, why you have to give the relationships. Okay, but the main point here is which relationship you have to give. This is very critical and this is very important. Okay, let me explain you how to pick a relationship type here. When this is your fact table, and let's say this is your dimension table, if these two dimension tables are directly related, that means foreign key relationship is there between these two, then the type of relationship is called regular. So in our case, this product is the dimension table, this one, and sales, fact internet sales is the fact table, and these two are related through foreign key relationship, and the common column between these two is product key, right? So this relationship will become regular relationship. In simple, when the fact table or measure group table, this measure group table and the dimension table are directly related. That means in database concepts, when these two are related using foreign key relationship, then that relationship in SSIS is called as regular relationship. Now let's see how these two tables are related. Fact internet sales and dim product are related directly using foreign key column. What is the foreign key column? Product key in the product table and product key in the fact table. So the type of relationship that we have to set between these two is regular. Let's see how to set the relationship now. First you have to select the regular from here. Okay, I selected regular. Now granularity attribute. You have to specify what is the granularity attribute. Granularity attribute is nothing but the primary key column of the fact table. Dimension table. In a dimension table, you will have foreign key. Primary key, right? How the primary key and the foreign key are related in foreign key relationships. If this is your fact table and this is your dimension table, you will have primary key here defined and you will have foreign key here defined. That means both are same columns and these two will be related. So as the granularity attribute, you have to give this primary key. What is the primary key that you are using in the dimension table? So let's try to give the same. What is the primary key column? That is product key. When I select this, automatically the dimension table is filled. The measure group table is filled. Why? Because it knows between what we are trying to, we click this button. If I click this button here, that means the fact table is this and dimension table is this. So it automatically taken that. Now dimension columns, the primary key column is set. What is the column for in the fact table which is acting as foreign key? The same product key. Now this is set. Let me explain this in database concepts. Select this table, inner join this table on dimension table dim product dot product key is equal to fact internet sales dot product key. Can you see that here? The same inner join query what we have given. This table, inner join with this table on, we have to give some condition after on, right? On dimension table dot product key is equal to measure table, that is here fact internet sales dot product key. So that is it. The relationship is set. If you click on OK, that will be set between the dimension and the measure group. So now the regular relationship is set between product dimension and sales fact table. So this is the intersecting point and the relationship is set. When the mouse is on, it will show you the relationship type is regular, granularity is product key, and the remaining information you can see here. Measure group columns is product key. Now, what will be the relationship between promotion and sales? To know that, you have to go to data source view where you will have the complete table information. So promotion is created, dimension promotion is created using table dim promotion, right? And fact and sales is created using fact table sales. How these two are related? These two are having a direct relationship. If you see, the promotion key is here and you can see the promotion key is here. That means direct relationship is there between these two, and hence the relationship here will become regular relationship. Why? Because these two are having foreign key relationship in the database, or in other words, these two tables are having common column, the common column to join. So now let me show you how to give the regular relationship. Here I have to go select regular. What is the granularity? It's a product promotion key. Automatically the dimension table and the measure group table is selected, and the dimension columns, the product promotion key is selected. Now you have to select the matching column from the measure group table, that is fact internet table. In our case, the common column is promotion key. If you select this, then that means the relationship is set. Okay, this is about regular relationship. Now let's process and see whether it is working fine or not. What is the difference between not giving the relationship and giving the relationship? Earlier, when I browse the data here, I'll show you just a second. When I browse the data here without giving relationship, it was showing duplicates. Now I have given the relationship. You can see I set the relationship between the product and the sales, and this attribute I dragged from product dimension, and this same one I dragged from sales. Now the relationship is set and the cube is processed. The next step what I have to do is I have to reconnect whenever I process the cube, so that it will fetch the fresh data. Let me reconnect and see what's going to happen. You can see the data is properly segregated for each English product name. So this is how, now this has some meaning. If anyone asks me what is the sales of Classic West, yes, I can say it is $10668. Earlier case, it was not the same, right? It was giving duplicate records, so I was not able to figure out what is the exact sales of a particular product. Now if you drag and drop some other column from the product dimension, you can see the color, sales, perfect. It is aggregating color wise. And if I drag and drop some other attribute like description, you can see the data. This is the description of each product, and this is the sales of each product with this particular description, and with this particular description the sales is $4451260.125. So this is the advantage of having relationship. If I don't give relationship, that means it is nothing. I cannot use this cube for anything. I can throw this in dustbin. Okay. Now we are done with regular relationship. What is the next one? Next one is fact relationship. How to give fact relationship and what is this fact relationship? Okay. Let's discuss about that first. Before going to the fact relationship, let's see the same again. Queries. Select distinct color from dim product table. Okay. So it is going to give me what are the different colors that are available in the product table. If I write a query for getting English product name, sorry, I selected the other one, English product name here, it will give you the distinct products. So as I told you, always, not always, 99% of the cases, the measure group tables are, what are the measure group tables? The transaction tables, where you will have transactions, right? The measure group tables or transaction tables are one and the same. But few cases, very few cases, the dimension table also act as fact table or measure group table. Okay, let me explain you one case. Now I have 10 products here. You can see 10 different products. If I want to find out how many products are there of each color, how can I get that? The count will become a fact table here. The number of records, the number of products available will become a fact table here. So if I write the query for the same to get what are all the, what is the number of products based on color, the query looks like this, comma, count is a SQL function to count the records, count of star. Now what I have to do, count is a function, so I have to use group by color, right? So what I am asking the server is to give me color wise count of rows from, grouping by color wise. If I execute this, it will give you the count of rows, count of products that are present for each color, right? Now this is your fact data and this is your dimension data. What is your fact table here then? The fact table is dim product. What is your dimension table? The dimension fact table is nothing but the one which is giving metrics for me for my analysis. It is dim product. What is dimension table? Dimension table is nothing but the one which is giving me descriptive data. That is also dim product. So a single table is acting as dimension table as well as fact table, right? This kind of scenario is called as fact relationship in SSAS. When the dimension table, whenever anyone asks you the question like what is fact relationship, the answer should be like this: whenever the dimension table and the fact table are same, or in other words, when people designed a fact table and the dimension table using the same base table, then that kind of relationship is called as fact relationship. So I have a dimension product from which I can get the color attribute as per this query. I'm going to achieve this query requirement, the same output in SSAS. Okay, the color is available. Now the pending thing is count. Now what is the requirement? I have to add one measure. What is that measure? The measure is not sum. It has to get me the count of rows of which table? Product table. Okay. If I click on OK, it has added one. I'll rename it as product count. Now a measure group is created using the table dim product, and a dimension is also created using the table dim product. So if you have a scenario like this, then if you go to the dimension usage, automatically the relationship will be set. I have not given this relationship. Automatically the relationship will be set. You can see this is your product dimension and this is your product fact table. The relationship is set, and if you click on this, the fact is selected by default. The common column is product key. What will be the common column? It is the same, and the dimension table is same, and product measure group table is also same. This is the only one relationship which you don't need to specify externally. You don't need to specify it. Automatically it will take. If it comes to know that the fact table is created using the same table that is used to create dimension, then automatically it will be set. Now, if I create a fact table using promotion, this combination will be set. Let me show you that by creating promotion. New measure. Again, I am taking count of rows. I want to see how many rows are present in the promotion. I am selecting it. Click on OK. You can see this relationship is set by default. So what is fact relationship? When the fact table and the dimension table are same, then the relationship that will be set between these two is called as fact relationship. This is the simplest one available in all the relationship types. Now the fact relationship is set. I'm good up to here. Now let me process it. Why? Because I changed some relationship. Whenever I change something in the cube, I have to process. This is the biggest headache we have in SSAS part. Now I processed it. Go to the browser. So I'm gonna execute the same part. I'm gonna retrieve the same data like color wise count of rows. Okay. I reconnected it, first part. And you can see one eraser kind of thing, right? This is used to clear the result. Whatever is here, it will be cleared. So this is, we call it as eraser. Okay. Make use of it if you feel like. What is the first thing as per this query? The color is the attribute. So this is the attribute in the product dimension color. Let me drag it. And what is the next one? Count of rows. Count of rows is a measure, and I have it in product dimension, product measure group. If I drag and drop it, you can see the data here. So this is how 133, 28, 1, 18, 2, 54, 63, 52, 7, 4 and 46. So the same requirement, whatever I have given here, when the dimension table and the fact table is same, then the relationship is called as fact relationship. Okay. Now we discussed about three relationships. One is no relationship, one is regular, and one is fact. And as I told you earlier, data mining is not in scope of these sessions. We will have to discuss about the remaining two. One is referenced and another one is many to many. Many to many is bit complex relationship type that is available. To be frank, the people who are working on SSAS, okay, if you take 100 guys, 90 guys, something close to 80, between 80 and 90 guys don't know how to set this many to many relationship. Or at least in the first year of their career on SSAS part or Microsoft BI part, they don't try to know this. Why? Because they feel it is a complex relationship. Okay. So what we are going to do now here is we are going to discuss about reference relationship in this session, and we are going to break this session after this reference relationship. In next session, we are going to discuss about many to many relationship. Reference relationship is very close to regular relationship, but the only factor is it is gonna take reference. For example, if you see, this is the query I have written. Sorry. To see the data, English description wise, what is the sales present? Okay. Let me take a simple one, color wise sales amount. So to get this, what I have done, I joined the first I get the sum of sales amount from the fact table and joined with the dim product table and on product key column, and I'm grouping by color. So up to here, so if you see the query here, I mean there was some problem in the screen sharing part, so I'm repeating the same thing again. So color wise sales amount I'm getting, and I have sales amount in fact table and color in dim product table, so I joined these two. So these two are having foreign key relationship, and this kind of relationship is called as regular relationship. Then what is referenced? Let's say, let me draw this. This is your fact table. Okay. This is your foreign key joining with primary key of the master table. We call it as regular relationship. When this table is having one more foreign key, okay, with another table which is having primary key. This is primary key, this is foreign key between these two, and this is primary key and this is foreign key. Now if anyone asks you what is the relationship between these two, this is direct relationship. If anyone asks you what is the relationship between these two, this is not direct. This is through some mediator, right? Or through some referencing table. These two has some reference in the middle. Without this, you cannot relate these two tables at all, right? So when you have scenario like this, then in that case the relationship is called as reference relationship. When the dimension table and the fact table are not directly related, and that when the dimension table is related through sorry, some other dimension table, this acts as a dimension. When dimension table is related to fact table through some other dimension table, then that reference is called as then that relationship is called as a reference relationship. Let me show you an example here. Let's go to data source view. This is your fact table. You can see everything is directly related. There is nothing which is not directly related to the fact table. Even if you see dim product, you have direct relationship with this. This is the product key. Sorry, I missed it. This is the product key and this is the product key, direct relationship. And if you see this one, customer, it is directly related, and dim time, it is also directly related. Now, what is then indirect relationship? What is the indirect relationship here? I don't want this table as of now. Let me delete it. Okay. What is the indirect relationship now? The indirect relationship is this fact table should be related to some other table through one of these tables. Okay. Let me add such kind of table. Add or remove tables I can use to add a new table or remove the existing tables. Now, my intention is to get all the related tables. This one is regular relationship, right? This is my fact table. If I click on add related tables, it will get all the foreign key relation, all the tables which is having foreign key relationship with this fact internet sales table. That means this one is directly related to all these. That means regular relationship with all the tables, right? Now reference means it has to go one step ahead. If any of these tables is having relationship again, then that is called as reference relationship. Now this product is having add-on tables. Let me drag that. You can see this is extra tables. Dim product category as subcategory is added. So if I click on OK, and let me arrange the tables properly. This is your fact table, this is your product table, and this is the subcategory table, right? To make the things more clear and visible, I'm gonna remove all the unwanted tables. I don't want currency at this point of time. I don't want customer. I don't want sales territory, and I don't want time. The picture will looks better now. That's why. Add or remove. Sorry. Refresh tables, and I don't want currency too. Let me delete it. And I don't want customer. Let me delete it. This promotion is I want it. Why? Because I used it in Cube. And the next thing, the dim product, I used it in the Cube. The newly added table is dim product subcategory. And if you see, the product key from here is joined with the product key in this table, and product subcategory key from here, this is the foreign key here, is joined to the primary key of the table dim product subcategory, that is product subcategory key. Now if anyone asks you how the table, how this table and this table is related, these two are not directly related. I cannot set the relationship without the help of this intermediate table. Okay. In database concepts, how we will implement this? We will implement this with one more inner join. Inner join dim product subcategory on dim product subcategory dot product subcategory key is equal to dim product dot subcategory key. Now imagine if you don't have this link in the middle, you cannot set this query. Why? Because you need this link. So this is how this intermediate table here, the dim product, plays a major role. It is acting as a reference table to dim product subcategory in order to join with fact internet sales. That's why we call this kind of relationship is called as this kind of relationship as reference relationship. Now let me show you how to do that. Before how to do that, you have to create one dimension for the newly added table, that is dim product subcategory. So we have created so many dimensions till now. So I hope you have a better idea. So that's why I'm just straight away creating without any explanation here. So I'll add all the columns, product categories, or I'll call it as subcategories. Finish. The next job I have to do is add this one to the cube. Now, I showed you how to give fact relationship, right? Now I don't want this anymore. Let me delete it. Why? Because we are discussing about reference relationship. So I added the new dimension to the cube, and you can see this is empty now. How this one is related to sales table? This one is related to sales measure group through product table, right? Now there are some criteria you have to keep in mind before giving this relationship. The first and foremost one is this intermediate table, the table with the dimension which acts as an intermediate one should be related. For example, if I don't have relationship here, I've given no relationship here, and if I give reference relationship here, it will not show that. You cannot see what is the intermediate dimension. It is not showing the product. Why? Because the relationship is not set. Okay, that is why you have to make sure that the product, the intermediate dimension table is related with the sales table, fact table. This is the first and foremost thing you have to check when you are giving reference relationship. Now let's give the reference relationship between subcategory and the fact internet sales measure group. So for that you have to select referenced here. What is the intermediate dimension? Now you can see product also added to the list. Why? Because I set the relationship. Product is selected What is how these two are related? How the subcategory and product are related? Subcategory and product are related through product subcategory key. This is the common column we have between these two. And materialize option, it's always better to check, and it has a big story. I will explain you once you become familiar with the reference relationship. Okay, check this is materialized and it won't throw any error, and even if you don't check it, it won't throw any error. I'll tell you the scenarios when it will throw error and when it will not. Now I check the materialize option, so the relationship is set. If I process the cube, it will be processed successfully. So this is done. The next step of what I have to do after processing is reconnecting the browser. It is reconnected. Now let's see the sales product wise. This is the product wise sales, and now I have subcategory also. If I drag and drop subcategory name, it will be collapsed. This subcategory has only one product and this is the sales, and this subcategory has only one product. This subcategory has three products in it and this is the sales, splitting. And even this helmet has three different types and each helmet sales is this much. So this is how you can set the reference relationship between a dimension and the fact table. That is the first thing you have to see whenever you are, the first thing you have to see is the intermediate dimension is related with the fact or not. The second point you have to keep in mind is the intermediate dimension attribute, product subcategory key. For example, in the product dimension, if you don't select this, thinking that I don't need this product subcategory key, if you remove this from here, let's assume, if you remove this from here, if you don't select this while creating product dimension, intermediate dimension, here you will not have key to map it. This is product subcategory key, but here no key is available, right? Product subcategory is not available, key is not available. Why? Because you have not selected it as part of the dimension. Most of the guys will do the same mistake. While designing the cube, they don't think about all the relationship. They will just think about the dimension what they're working and the fact table what they're working. They have to keep all the dimensions in mind whenever they are working on the dimension design. So what we have to do in this case? Add it back, go to the cube, select the reference relationship. The intermediate dimension is product, select it. What is the common column between these two? This is the common column between these two and it is done. Now, let me add one more reference relationship. That means the table that is having foreign key with this table, right? Let's see what is the table. Add or remove tables. I'm going to add one more. If I select this and click on add related table, I will get one more. If there is any, I got one more which is having relationship, that is categories. So categories is parent, its children is subcategories, its children is products. Okay. If I click on OK and arrange the tables here, you can see this fact internet sales is related to product, product is related to category, subcategory is related to category. Now, what is the first step? Again, it's creating the dimension for the newly added table, that is category. So created it. Let me select everything. Finish. Now the next step is adding this one to the cube, adding newly created dimension to the cube, that is dim product category. Now if you see, the relationship is not set. How this one will be related? This one also will be related using a reference relationship. How many levels? It won't worry. It won't think about how many levels you have. If this is your fact and this is your first dimension, these two are regular. And if you have second dimension like this, then these two will be referenced. And if you have third dimension like this, which is having relationship like this, these two are referenced again. And if you have fourth dimension like this, then this one is, these two are reference. It won't bother how many levels it is. What it will check is to give reference relationship for this one, these two should be related. That's the first check. To give reference relation for this, these two should be related and these two should be related. Okay. Now here in our case, what will be the intermediate dimension for this dim product subcategory and measure group sales? It is not product. It is subcategory which is having common column with product category. Now if I give reference relationship, the intermediate table will become subcategory, and this subcategory and the product category has a common column, that is product category key. Now if I don't give it as materialized, then it will throw error. Only one level it will accept. One level with or without check it will accept, but for more than one level it has to be checked. I will explain you why it is. Okay. More than one level means this is the first level of referenced. This one is joining with product to sales, and this one is taking the help of the subcategory. So when you see the product to sales, it is related like this. It will come from here and join. For subcategory, it will go here, and hence it will go to the product, and then it will come here, it will join. For subcategory, it will come here, it will join with this, it will come here, it will join with product, and then it will join to the sales. So this is the first level of reference where it is using product. This is the second level of reference where it is using subcategory. So when it is more than one level, it has to be materialized. Materialized means nothing. It is not gonna do anything special. What it is gonna do is it will join these two queries and make it as a single query. And if you materialize this one also, it will join these three queries and make it as one query. That is product, subcategory and category as one query, and execute while processing. Keep in mind, when you have more than one level of a foreign key relationship, then the option materialize needs to be checked. So now we have given reference relationship at level 1 and level 2. Let's process and see whether it works as expected. So browser, let me reconnect. Is it not processed or it is processed? Let me process it again. Succeeded. Fine. Now reconnect. You can see a new dimension is added, which is parent to this English product category, right? So if I select this category, it will be like under accessories, you have all these subcategories. Under this particular subcategory, you have these products. In the same way for clothing and bikes. So this is how people used to browse. And the major advantage is you can slice and dice. You can dice it. From here, you can push it to this location. You can see this is subcategory. For this subcategory, this belongs to accessories, so it has data. The subcategory does not belongs to bike, and hence it is having blank value. And in the same way for clothing. Okay, a product can belong to any one of the subcategory, any one of the category, and hence you can find value for any one of the column of these three. If you ask me what category this caps belongs to, means wherever it is having value, it belongs to that category, that is clothing. Helmets, it belongs to accessories and hence it has the values. Mountain bikes, it belongs to bikes and hence it has the value. You can split and see even list level data like this. So imagine, can you generate a report like this using SQL Server or any other things? It's pretty difficult. It's very, very difficult, I can say. So that is why this analysis services has a great boom, because it makes the analysis part of any business damn easy. Okay. So this is about the relationships. I mean what we discussed about. No relationship, regular, fact, and reference. So that's it for today's session, for this particular session, and we will discuss about many to many relationships in coming sessions. In next session, I can say. Okay. Thank you.